Here we have OpenStax chapter 6 number 38. So I'm going to start by drawing a picture, and I'm specifically paying attention to the fact that it's 35 degrees with respect to the vertical. That's very important. So if here's the ceiling, here's my ball, there's the string here. The angle that's 35 degrees is this angle here with respect to the vertical. To keep things simple, I always like to know what is the angle with respect to the horizontal. So the angle with respect to the horizontal for this object would be 55 degrees. So this is the angle that I'm going to use. If I look at drawing my free body diagram on this object, I'd have the force of gravity pulling straight down, and tension would be pulling upwards at an angle of 55 degrees with the horizontal. So this is what my free body diagram looks like before I break things into x and y components. And again, this tension is pulling upwards where the angle with the horizontal is 55 degrees, right? Because look, you can see here that this angle between the ceiling and the string is 55 degrees. That means that's also going to be the angle between the string and the horizontal here. This angle down here is 55 degrees. The 35 degrees is this part up with the vertical. So when I break my tension into horizontal and vertical components, the component, and t is like the magnitude of that vector. So the vertical component gets t times sine of 55, because 55 is my angle with the horizontal. And the horizontal component here gets the cosine of 55, so that's t times cosine of 55. I don't know what t is. And in fact, they ask me in part B, what is the tension? So to figure things out, I'm going to look at my net force. First, let me look at the net force in the y direction, because I know there's no acceleration in the y direction. This whole thing is inside of a freight car. The freight car is accelerating to the right in this case, as I've drawn my picture. Since the freight car is accelerating to the right, there is an acceleration going to the right, but there is not going to be an acceleration in the vertical direction. So I'm looking at my net force in the y direction, and in the positive y direction, I have t sine times sine of 55 degrees. And then in the negative y direction, I have mg. Since I'm not accelerating in the y direction, my net force in the y direction has to be equal to 0. So now that if I plug in the numbers for the mass, and remember, mass always has to be put in units of kilograms. They told me that the ball has a mass of 20 grams, so I need to convert that to kilograms. That would be 0.02 kilograms. So I'm plugging in all my numbers here, and then I can solve for the tension. So I know the tension is 0.239. That's the magnitude of the tension. If I wanted the y component of tension, I would do 0.239 times sine of 55. When I want the x component, I'm going to use that magnitude times cosine of 55. And when I look in the x direction, I do need to use that x component. So the net force in the x direction is just simply this force of t cosine 55 pulling to the right. My net force in the x direction is always, always, always equal to my mass times my acceleration in the x direction. And now when I plug in all the values that I know, it's going to let me solve for my acceleration in the x direction.